Today we're going to create a weld using ArcWelding Power Pack 1. This is assuming you have a virtual station and controller set up for welding. If you don't, then watch my previous video on how to set up a virtual station on my channel. The first thing we need to do is activate the ArcWelding add-in. To do this, you can go into the Add-ins tab and click on the ArcWelding Power Pack tab. After the ArcWelding Power Pack tab loads, you should have another tab that appears that's listed as ArcWelding on the left side of the menu. Open that tab to show the options available to you in ArcWelding 1. Once you activate ArcWelding, you need to create a part program. To do that, we're going to hit Part Programs in the ArcWelding tree. Right-click on it and create Part Program. It opens a menu where you can name the part, module, and routine and path names. I typically name the part with a customer name and a 4-digit sequence based on the last 4 numbers of the part serial number. For this part we're doing right now, we don't have any specific customer, so I'm just calling it Weldament, and then 0001. Once you rename the part and or modify the paths how you would like to have them modified, you can hit OK to create that part program. Once you create your part program, you can hit this add arrow under the part program and double click on the routine within that program tree to open up that process path. That routine can now be seen in a path view below the Robot Studio station screen. From this bottom window, you can add and edit instructions, targets, and arguments. So in this, we're going to create a weld. Typically, I first put in action instructions. I add to every weld instruction before I create the weld. I want to turn off all displacements from previous instructions before I weld using the pdisp off command to make sure there are no prior displacements are set before welding. To add this action instruction, I'm going to hit this create menu and I'm going to go to action instruction. And on the right hand side of the screen, that is right to the viewing screen, we see that create action instruction menu, and it has instruction templates. I'm going to hit pdisp off, hit OK. I'm also going to create a second pdisp off to put at the end of my weld routine. So I have 2 pdisps offs, one for the beginning and one for the end. And I'm also going to go in here at the beginning of my routine and activate my positioner since I have a positioner and will be using it for programming. So on this one, it wants me to activate the unit, but it also needs me to select what unit I want to activate. We don't have to activate the robot, but we do have to activate the skyhook, which is station 1. If we were doing a weld routine that included searching, I would also add after the first pdisp off a pdisp set for any displacements that need to be set for adaptive welding that uses tactile sensing. But since I'm not searching at this example, I'm going to omit that instruction from the process path. After I get all my action instructions in place, I am then ready to create a weld. I select the first P-disp off, just so I get in the right order here of the stack. And then I'm going to hit the Create button, and I'm going to select Weld. A split menu screen appears to the right on the station screen, and under Screen Run, I'm going to select the application template I want to use. Since I am arc welding, I'm going to use ArcWelding. With a lot of the welds I do, I incorporate weaving and tracking, so I'm going to select Arc Default with Weave, so the weave argument is placed in the instructions. After I select the template, I'm going to select the tool I'm going to use. We have an option of Tool 0 Benzel, and the laser was selected on Benzel, which is the one I want to use, so we're going to keep that. And I'm also going to select the work object, which has already been defined for me as OB Station 1, and I'm going to keep that since in the future I'm going to be using coordinated welding. I can also set the approach offsets for my pounce point prior to my arc start, the angle of the tool relative to the surface of the part I'm welding, and the offsets for my depart point relative to the arc end position. I'm going to keep everything standard right now. It's going to give roughly a 2-inch offset in the tool Z direction for my approach and depart point. And it's going to create a 45-degree offset on the angle about X from my base plate. And I'm satisfied with that, so I'm going to be okay with that. Now that we've set everything we need to in screen 1, we're going to go to screen 2 on that menu option. And then I want to first select what kind of weld I'm going to be making. I have options of making linear segments, circular segments, multiple segments, and a path from an edge. Right now we're just going to do one linear weld, so I'll keep it on one linear segment. I can also set my reference coordinate system if I want to. I'm not going to worry about that since I'm selecting my target with visual snapped options in the virtual model. And then it gives me an option. It's on the black arrow. It's telling me where I want to start my weld and give that first weld point. So I'm making sure that I have a surface or a body selection with a snap object filter on. I'm going to point to my start of my weld. I'm going to weld this square, this edge right here on this box. We're going to start welding here and end welding here. So I'm going to select the start point with my visual snap. Then it's going to ask me to select the end of my weld. I'm going to hit that. And then it's going to ask me to modify my base plate normal. So what's the base plate that's normal to the joint at this weld? And we're going to select the plate that's below the box. And make sure that arrow is pointing perpendicular and away from that box. And now that we've done all that, we can go to the bottom here and hit OK. As you can see, once you create a weld, here in the bottom, it's created a routine and a sequence. And the blue arrow, the blue tool-like object is showing you the position and the orientation of the weld gun in reference to the welding. The tool is not located in the right orientation. It put the 45 degrees offset on the side opposite that I wanted it to, so I have to modify that. To adjust targets, you can select the target below and modify the target. And once it says you modify the target, it gives you the target reference you want to use. If you want to rotate about a specific axis, an offset you want to create on that target, and then the orientation to X, Y, and Z. So as you can see, it created the offset at a negative 45 degrees, We're going to go a positive 45 degrees, hit enter, and then also I'm going to switch this around to a 90-degree angle instead of a negative 90-degree angle. And hit apply. So now that we've modified that first target, we can also modify our second target to match the start and end points. You can either do that doing the same instruction, same routine that we just did, or you can make sure that first target is selected, hit shift and select the targets in the path, right click on that, modify the target offset angle on selection, and that's going to apply the same offset that you want on following targets with the targets that you've already modified. So we can do an offset. We can keep the offset, which is there's no offset, so we don't have to mess with that. The most important thing we did is we're matching the angle, matching the same angle from the first target to the second target. You hit OK, and it's going to modify all the targets that have been selected to match the one that you've already modified. So now if we look at that, the targets are matched up. When you modify an arc start and an arc end point, you don't have to modify the approach points because they'll copy the orientation that the arc start and arc end points are at. Once you have had the targets modified, you can jump, move, and play through the instructions to make sure the robot can reach and move through the points you've selected. To do this, you select the targets you want and then click jump to or move on the commands. So we'll do the jump through option first. So we'll select the first point. We're just going to hit jump to, and the robot TCP is going to jump to that point. And if it can't jump to it, it's going to say that it can't. Right now, it looks like it can make it. There's no joints that are overly stressed right now, so that looks okay. We can jump to the next following points and make sure they look okay. Everything's looking okay. And jump to the target. There's no erratic change in configuration. So now we're going to play through it, make sure the robot can play through it. It played through the motion okay. There's no indications that the motion can't be accomplished by the robot. And when you play through and move through targets, it also sets the robot joint configurations on the joint target motions. After we've jumped and moved through and played through the instructions, the motion is smooth and consistent. Next thing I do to create a weld is I'm going to create air moves from the home and safe position to the pounce points leading up to the welding. The way I prefer to do it is I go to the beginning of the instruction and create a move absolute J instruction at the home safe position. A move absolute J instruction maps out each individual joint position and keeps it at a hard set location. And I know the joint position of the robot prior to the instruction and that the joint configuration won't change at the start. To do this, I jump the robot to the home position. Go back to the ArcWelding tab. I'm going to create an air instruction after the first PDISP off. And use the present location in the home position. Once I have that location set, I like to create an intermediate target between the home position and the pounce point to smooth out the robot path with a more controlled approach path. To do this, I create an air joint instruction at the pounce point. And then making sure my target filter is selected. I'm going to select the target I just created. And I'm going to use the motion handlebars to drag it in an intermediate relaxed point. Then I'm going to move to that instruction to make sure it looks okay. If I create multiple move instructions on my approaches, I like to set the motions to a linear instruction as I get closer to the weldment. The linear instructions base their motion on the configurations and orientations of the previous target, making them more repeatable and controllable. If I am not approaching singularity, those linear instructions should work fine. To change a joint move to a linear move, select the target and hit the Move J to Move L icon that's above the target. And then move through the instruction to make sure all the motion looks okay. Once I create the approach points, I then create the depart points to home in a similar fashion. In this step, I want to make sure the robot's depart path to home won't result in any tool collisions with the part. This can be ensured by creating an intermediate point between the pounce point and the home position that moves out and away from the part. After I create all the air instructions and targets, I play through the entire routine to make sure the operation runs as intended. As you can see here, I switched up my depart point with my air move to the home position, so I'm just going to change that real quick. Once I've played through the whole instruction, then I have an option to save out that path in Robot Studio as an XML file to an external location. To do this, you can save it by right-clicking on your part program, making sure it's closed out first, and hit the export path function. Name your path. And save it to where you want to put it. It's going to ask you where you want to put it, the path file you want to put it at, the file name, the reference you want to include, which we're going to keep at OB Station 1, hit OK. And now you've created, loaded, and saved a Weld program in Robot Studio. Thank you for watching, guys.